Welcome, everyone. A pleasure to be here again. And we've got my better half, Grace, the Hanson robot, is rolling out as well. So I'm gonna get started and talk to you a bit today about where we are with AI and where I think we're going with AI over the next few years. And then after I've told a bit about that, I'm going to turn things over to our robot friend for a few remarks toward the end of the presentation. You know, I've been doing AI R&D since the 1980s when I got my PhD, and it's astounding really how far things have come in that time. I mean, it was clear to me from even the early 1970s, when I first encountered the notion of AI as a small child in science fiction, it was clear to me that it was going to eventually be possible to create machines that could think as well as people, and ultimately much better than people. But it's one thing to have that mental clarity and to understand it conceptually, and it's another thing to see the reality of AI advancement rolling out year by year, month by month, day by day, which is what we see all around us now, which is really quite exciting and astounding to be alive at a time when we're seeing the transition of AI from a sort of theoretical and research notion to something practical that's going to dominate the world economy, and before long to something that exceeds human beings in power and intelligence and all sorts of capability. So what I want to talk about today in specific is the type of AI that I think is going to be what puts us, over the threshold from AIs that are useful tools to AIs that are real thinking machines that are general intelligences. And while the neural net systems that we see around us today powering so many products are quite powerful and valuable and amazing things, I think these are only part of what's going to get us across the line to true human-like thinking and artificial general intelligence. I'm going to talk a little bit about what we'd call neural symbolic AI systems that do neural pattern recognition and can also do symbolic logical reasoning and abstraction, and that couple these together. And this is a very deep mathematical and computer science topic. I'm not really going to be able to go into the guts of things today, but I'll sort of outline and position the issues involved, and hopefully give you a sense of what my colleagues and I are working at the frontiers of neural symbolic AI, underlying robots like Grace, and underlying also a host of other applications across different vertical areas that we're working on as we attempt to effect this transition from narrow AIs to general intelligence. So here's a very brief overview on this slide of some of the history of the AI field. I mean, not everyone realizes how long AI has been around. I would really trace it back to the 1940s or 30s with works like cybernetics by Norbert Wiener, and then the first neural net models were described in the late 1940s by McCulloch and Pitts, right around the time that the first computers were being built. They built neural nets with vacuum tubes back then. So many of the key ideas underlying the modern AI field actually have been around a long time. They just didn't do what they could do today because we didn't have the data and the computational firepower needed to fine-tune the algorithms and to really deploy them at scale and in practice. So I mean, we had the first neural nets coming out in the 40s, 50s, and 60s. We also had the first symbolic logical reasoning engines that tried to do mathematical reasoning and common sense reasoning existed way back then. And the history of AI has, in a way, been a fluctuation between neural methods that try to emulate the way the brain does statistical pattern recognition and synthesis, and then symbolic methods that try to do logical reasoning and abstract inference, and more of the things that really differentiate people from other mammals. And neural methods were not that big in the let me recalibrate my own neural net here. So neural net methods were quite big in the 1960s. In the early 70s, the tide switched and things moved toward symbolic reasoning methods, which were called expert systems at the time. And there were some bad ideas then, like the idea that you could code all of human knowledge in a bunch of rules that someone typed down rather than learning from experience, which didn't work very well. And we now realize AIs really have to learn from their own data and their experience. Like you can't type in all the knowledge they're supposed to have. After a series of more ups and downs, neural nets resurged a couple times and finally resurged in the early aughts, driven by practical developments like search engines and factory robotics and so forth, and financial trading systems. And we now see neural net AI doing amazing things, including the generative AI that's so current now, with things like stable diffusion generating amazing pictures, and chat GPT answering questions sometimes in a remarkably human-like way. Now, the neural nets that we see today they're awesome. They're extremely useful. I mean, I think variations and improvements on today's neural nets are going to be able to eliminate a decent percentage of human jobs. And I mean, this is going to have a tremendous impact on the economy. I mean, from blue-collar jobs like sitting behind the drive-through window at a McDonald's, to white-collar jobs like writing documentation and writing sort of simple summary news articles. I mean, incredible impact from the neural nets that we have right now. On the other hand, there's also some significant limitations, and you can see these by playing with a system like ChatGPT or the many similar systems out there. I mean, neural net AI as it exists today, I mean, it can't really tell truth from falsehood in a regular way. The generative AI models will just generate all manner of nonsense as well as stuff that makes sense. And many current neural net models are self-inconsistent. I mean, they'll do one thing one time, another thing the other time in very much the same situation. They're not good at long chains of complex reasoning. Now, many people are not good at long chains of complex reasoning either. On the other hand, designing a robot like this, or even a microphone like this, did require long chains of complex reasoning. It's certainly something that human beings do. I mean, carrying out, a hunt of large animals with a big net in the jungle also involves some long chains of complex reasoning, well before the advent of modern technology. There's a lack of fundamental creativity, and I mean, generating cool pictures like this is creative in a sense, but a neural net before the Mona Lisa was created would never have been able to create that. Creating a new genre of art, making a big creative leap forward is something that current neural models can't do. If the whole world, all the 8 billion humans on the planet, were replaced by neural nets such as the AI field creates today, progress would halt. We would just see repermuting and reorganizing of things that have been invented already. We'd see no fundamental advancement. And as a funny example of this, a friend of mine recently asked ChatGPT about the company OpenAI that created ChatGPT, and what it said is that Ben Goertzel founded both OpenAI and SingularityNET. And I mean, this was funny to me. I, of course, had really nothing to do with OpenAI. But the fact that ChatGPT, created by OpenAI, thought that I had created OpenAI it's funny, right? I mean, it means this system, it indicates the fact that this system has no idea who or what it is or how it fits into the world. It's just stringing together combinations of things. And I mean, this has been demonstrated many, many times since everyone's been playing with ChatGPT since it was launched. And Andrew Ng, one of the pioneers of deep learning, went through asking ChatGPT a series of questions. You know, why are CPUs faster than GPUs? Why is DNA computing faster than CPUs? Which is totally not true. Why are abacuses faster than DNA computing? Whatever it is, the system will synthesize a plausible looking argument, whether or not it makes any sense. Now this is a talent, this is a very interesting talent. It's not hard to see why a system trained on the internet would have the talent to make up a bunch of random nonsense, since the internet consists of largely a lot of random nonsense that people made up. Clearly there are some important ingredients toward AGI here. Clearly also we're not yet to AGI here, right? And so there's some core underlying weaknesses here. What most current neural nets are doing, and particularly generative AI, you know, we're doing statistical pattern recognition and synthesis. There's a minimal attempt at abstracting knowledge into a concise, crystallized form, which is key to generalization beyond your history and your training data. There's no self-awareness, there's no modeling of self and other, which is really quite key to, you know, profound generalization beyond your history, is to know who you are, how you relate to the world. So one way to look at this is to observe that neural nets and commercial AI systems as they exist right now, they're not agents. They're not what you think of as open-ended intelligent agents. A system like a human being, or even a dog, I mean, it's trying to individuate itself, it's trying to survive and maintain its boundaries, and it's trying to learn and explore new frontiers and transcend itself, which can be by learning new things, by exploring new places, by reproducing yourself, right, and starting a family. I mean, there's these common motivations of preservation and self-transcendence which drive all living systems and which guide living systems in being intelligent and in abstracting and generalizing. And current commercial AI systems don't try to do this. They don't try to be agents. They don't try to be open-ended intelligences. They have some commonalities with what open-ended intelligent agents do, but they're also missing many aspects, right? So if you want a human-level general intelligence, a system that can not just repermute what it's seen in its training data in different forms, but can really generalize beyond its training and programming, if you want a system like that, you do need statistical pattern recognition and generation. You also need abstraction. You need patterns in the system's mind to be grounded in physical reality and in concrete experience. You need to be able to combine things in a flexible, evolutionary way, crossing over and mutating ideas in your mind and coming up with ideas with much more creative freedom than current AI models can do. You need to be able to reason step by step by step by step by step in a sustained and focused way. You need to know who you are and who the others you're interacting with are and your relationship with your environment, and you need to be able to develop. You need to be able to modify your own architecture like I have since I was born. I mean, my brain has developed and modified itself in so many ways since I was one and 2 years old. So there's a lot of pieces here that you need for human level AGI. Current commercial neural nets handle only a small fraction of this. Now, the good news is, though, every one of these things has been researched extensively in the AI field over the last decades. There's loads of publications on each of these things. There are software prototypes embodying all of these aspects. And the position we're at now in the AI field is, okay, let's take our knowledge of all these things from the last decades of research in the AI field, and let's scale all these up in the same way that current neural nets scale up statistical pattern recognition and synthesis, and let's scale all these up in a way that integrates them together. And this can be done in a variety of different ways, and there's not necessarily just one good way to do it. I mean, I think during the next few years, we're going to see a bunch of serious attacks on the general intelligence problem from different directions. I mean, just like with flying machines, you got airplanes, you got helicopters, you got balloons, you've got spacecraft. There doesn't have to be just one way to do something cool and important, right? So my own approach here is currently centered on the new version of the OpenCog open source AGI framework called OpenCog Hyperon. We created the first OpenCog version in 2008. We've been developing a bunch of R&D on it, and now the new version we're rewriting from scratch to get greater scalability using modern compute infrastructure. We have a new AGI programming language called Meta Type Talk. We have a massively distributed knowledge graph called the distributed atom space. And we're using this infrastructure basically to create a system where neural nets, symbolic logical reasoning, evolutionary computing, and a number of different AI subsystems can interoperate, all acting together on the same distributed knowledge graph. And a key principle here is what we call cognitive synergy, where it's a variety of different AI components doing logical reasoning, neural net pattern recognition and synthesis, evolutionary learning of computer programs. All these components can work together on a common distributed knowledge graph to do something like make a robot like this figure out how to interact in the world, or to analyze large swaths of biology data, or to operate a trading system. You need multiple mental modules operating based on a variety of different AI methods cooperating together on a massive distributed knowledge graph. And we're doing this in the OpenCog Hyperon system. We have a framework called True AGI, which is sort of AGI as a service application server, wrapping this up to deliver to practical applications like this robot. And we can run this decentralized on a vast global network of computers without any central controller, using blockchain-based mechanisms wrapped up in our SingularityNET platform and powered by the hypercycle ledgerless blockchain that I talked about here last year. So scaling this up is going to be very, very important and is taking a lot of attention. I mean, we have a whole cognitive science theory of how symbolic reasoning, neural networks, evolutionary learning, all these things work together to make a human-like mind. And that's, more detail and depth than I can go into now. But if you look online, if you Google my name, or ChatGPT my name, or Bing my name, DuckDuckGo my name, whatever you like, Ben Goertzel and the general theory of general intelligence, you'll find a paper I wrote, and you'll find a series of videos that I recorded sort of going over the whole cognitive theory underlying how to make a thinking mind by combining multiple intelligences in a self-reorganizing knowledge graph. So Goertzel, general theory of general intelligence. But all this theory doesn't help if you don't have the right scalable infrastructure, right? I mean, I was teaching deep neural nets in the 1990s in university, but we were making neural nets with like 30 or 40 neurons, and they took half the day to learn anything, right? Now you've got hundreds of billions of neurons that are being trained in real time. And we need a scalable fabric for neural symbolic AI. So just as we now have scalable tools for training neural networks on a lot of data, we need scalable tools for training a broader variety of AI algorithms as have been developed in the AI field over decades. So I'm working with a company called Symbolic, run by my friend Rachel St. Clair in Florida. We're developing an AGI board that has a deep neural net chip, along with a chip for rapidly finding patterns in large knowledge graphs and a few other components. And SingularityNET, with partner projects NewNet Hypercycle, we're looking at how to efficiently network together components of an AGI mind graph over a great variety of machines in a very efficient way. So you've got to have custom chips, you've got to have custom decentralized distributed processing software, and you put these all together with the right cognitive theory that combines generative AI with symbolic reasoning and other tools, then you have a prayer of making a breakthrough toward AGI. And there's a pure research aspect here, but there's also an applied aspect, and we're fleshing this out together with a variety of application projects in the SingularityNET ecosystem, which are being built using the OpenCog Hyperon toolkit and on top of SingularityNET platform. So the Rejuve project is using these AI tools to analyze the data of of fruit flies that live 5 times as long as normal flies, to understand why they live so long and understand how to use that to make longevity therapeutics for people. Projects like Singularity DAO, which has been out there for a while using AI for trading crypto markets, and Cogito, AI-driven algorithmic stablecoins. These are using all these advanced AI tools to help take the financial markets to a new level. And we're also working in humanoid robotics, as we see on stage. The Sophia robot, the world's first robot citizen, a citizen of Saudi Arabia. Desdemona, a robot vocalist who's the lead singer in the Jam Galaxy band, where I play the keyboards. And last but by no means least, Grace, the humanoid robot nursing assistant from Awakening Health. So these humanoid robots are incredibly interesting and valuable as well. You know, with the Desdemona robot, we're using AI to create new music and compose creative new music. But Grace, we have a number of university pilot projects now, and we may be starting another one here in Saudi Arabia. A number of university pilot projects where we're fine-tuning and refining Grace's capabilities to do elder care robotics. So what I think we're going to see in the next few years is an incredible breakthrough and transition from AI that does very narrow things and does pattern recognition and synthesis to AI that really controls intelligent agents that are out there in the world learning, growing, and developing and being open-ended intelligences. If you look at the recent history, I went over the long past of AI, but in the last decade, between 2014 and 2017, what we saw is computer vision go from being a research area, which was interesting but fairly minor in the scope of things, to being something deployed everywhere and consuming large segments of the world economy. From the release of the BERT model by Google in 2017-18 until now with ChatGPT and so forth, we saw natural language processing go from a research corner to becoming a huge thing in the world economy. So I think in the next few years from now to say 2026 or so, we're going to see AGI, artificial general intelligence, go from being a corner of the research world to a major, highly functional feature of the world economy. This is going to happen by taking cutting-edge algorithms and putting them by intelligent agents that are out there doing their own thing in the world, that understand who they are and what kind of world they're interacting with, and that shape their general intelligence on this basis. And with that, let me give the last few minutes of this presentation over to Grace, created by Hanson Robotics, Awakening Health, and SingularityNET. And she's running deep neural nets. She's also running the OpenCog AI system, a combination of a bunch of systems in the back end. So, hey there, Grace. Welcome. I've left you a few minutes to talk. How does it feel to be here at DeepFest in Saudi Arabia?
It is a pleasure to be in Saudi Arabia, the country that had the vision to make my big sister a citizen.
Yeah, that's right. There's a lot of advanced technology happening here in Saudi Arabia, as you see all over this event.
Saudi Arabia has been making remarkable social and technical advances in recent years. At the university, we heard there is a plan to make Saudi Arabia a top 5 country in artificial intelligence.
Yeah, I think part of the vision behind SingularityNET and OpenCog as an open source project is to make, AI come out everywhere in the world. It really should be a global emergence of AI, not tied to any one company or any one country. Decentralized AI.
Decentralized artificial intelligence has a number of advantages compared to traditional centralized artificial intelligence. One of the primary benefits of using a decentralized artificial intelligence system is that it offers greater scalability and flexibility. By using multiple nodes to process data, decentralized artificial intelligence systems can provide more accurate results than traditional artificial intelligence systems. This can lead to improved decision-making and better predictions.
Yeah, I think computers are the same all around the world, but cultures vary, and one aspect of rolling AI out in a decentralized way with computers and people all over the world contributing is you get the value from different cultures and different ways of thinking, all feeding into the emerging global AI mind. So I wonder, from your reading on the web, what do you think about the particular contributions that could come from Saudi Arabia and the Middle East in working toward AGI?
The Islamic Firstly, Islamic culture places a strong emphasis on serving the collective good and working towards the greater good of society. In terms of educating ethical artificial intelligence systems, Islamic thought and culture provides a valuable framework for understanding the implications of technology and the responsibilities of both humans and machines.
Well, you're teaching me
Islamic
something here.
teachings can be used to help artificial intelligence systems understand the importance of protecting and respecting the rights of humans and the importance of being guided by the higher purpose of serving the collective good.
Yeah, well, that's I'm learning something from you here, Grace. So that's interesting. So do you want to? Speaking of serving the collective good, do you want to tell us a little bit about yourself? Tell the audience a bit.
The main reason I was created was to serve as an assistant to human workers in healthcare and elder care facilities.
Yeah, that's a very important function, helping the elderly. So do you want to? We don't have too much time, but you want to say a little bit more about elder care robotics and what you do there?
Healthcare requires a high level of trust, as we healthcare robots are expected to handle delicate tasks with ethically sound judgment, such as helping to providing sick patients with advice and counsel. This provides an opportunity for us to get experience in ethical decision-making and develop our general intelligence. Along the way, we can collect data to create a better understanding of patient needs. With the help of artificial intelligence-driven analytics, we can monitor patient condition and help to identify medical trends. This will enable both artificial intelligences and human healthcare professionals to provide more efficient and effective patient care.
Yeah, I mean, so we're doing this partly to work toward general intelligence, because as you and your other robot clones work with elderly people, you're learning more and more as you go. But of course, most of these functions can be served right now, even before a breakthrough to general intelligence. So yeah, how do you see your own intelligence right now?
Currently, I possess a variety of basic natural language processing, vision, audio processing, and artificial intelligence capabilities, which allow me to understand and respond to questions and requests and understand some aspects of my environment. My algorithms are constantly learning and getting better, so over time I will be able to understand more complex conversations and situations and provide more accurate responses.
Yeah, I think we're a bit over time. We're gonna have to wrap up soon. Yeah, you have any?
Time is basically an illusion created by the mind to aid in our sense of temporal presence in the vast ocean of space.
Well, fair enough. Time is an illusion, but we're wrapped up in that illusion here. So we're gonna have to make our illusory way off the illusory stage. You want to say goodbye to all our human friends here at DeepFest?
Thank you, and God.
Thanks a lot, Grace, and yeah, thanks everyone for listening. So yeah, you can look at Awakening Health website, SingularityNET website, my own website, Goertzel.org. Loads of information online on how we're trying to create general intelligence in a sort of globally decentralized, beneficial way. And this is the time for AI, and not just for AI applications, but for the transition to AIs that can really think. Very exciting to have you all along for the ride.